The fifth question says, find perpendicular distance from the origin to the line joining the points this and this. Okay, there's a line joining the points this and this. We are supposed to find the perpendicular distance from origin. Okay, the perpendicular distance from origin will not be difficult, but first we have to find the equation of the line joining these 2 points. Right. So let's go ahead and do it. For writing the equation of line, we are given 2 points. So let's use the 2-point form. Now, what does the 2-point form look like? Equation of line in 2-point form will be y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. This is the form which we are interested in, right? So let's write this y minus y1, which is sine theta, is equal to y2 minus y1, which is sine phi minus sine theta upon cos phi minus cos theta. Okay, and this is x minus cos theta. This is what you have. Is that okay? Yes. That's the equation of line. Yes, that is the equation of line in one way. But can we simplify this further somehow? Yes, maybe we can simplify this in a particular way. What is that? This is sine C minus sine D. Okay, do you see sine C minus sine D? Yes. Can I apply concepts of trigonometry over here? Yes. Transformation of sum or difference into product maybe. Yes. So what is sine C minus sine D equal to? Let me write the formula somewhere. Let us use this particular space for writing the formula of sine C minus sine D and cos C minus cos D. So sine C, let's see, sine C minus sine D is equal to 2 cos C plus D by 2 sine C minus D by 2. This is what you get, right? 2 cos C plus D by 2 sine C minus D by 2. What about cos C minus cos D? This is equal to minus 2 sine C plus D by 2 sine C minus D by 2. So using these formulae, you can maybe transform this complicated expression into a simpler expression. Yes. So sine phi minus sine theta will be 2 cos theta plus phi plus theta by 2, phi minus theta by 2. Okay. And similarly, this term will be this, and you observe that sine C minus D by 2, sine C minus D by 2 will get cancelled, right? 2's will also get cancelled, and what will remain is simply cos of theta plus phi by 2. This is what will remain. In the numerator and the denominator, you will get minus of sine theta plus phi by 2. Right? Using that formula, I am directly writing this. Okay, you can write the middle step as well, but this is what you get. And with this you get x minus cos theta. Okay, and this here is y minus sine theta. Let's simplify a bit further and bring this expression over here. So what do you get? Y times with a minus sine of theta plus phi by 2. Okay, and this becomes plus sine theta sine of theta plus phi by 2. What else? On the right hand side you get x times cos of theta plus phi by 2. Okay, and you can multiply this and get another term over here, and what is that? This is minus cos theta times cos of theta plus phi by 2. Do you observe this? Yes. Oh, this expression looks pretty long. Yes, this expression looks pretty long, but you can bring that y over here and take this term over there to simplify it further. What does it look like after simplification? Let's take a look at this one. After simplification, this will finally convert to, let's bring everything on the y term on this side and take this cos theta term over there. So x cos theta plus phi by 2 is what I have over here, plus y sine theta plus phi by 2 is the other thing that I have over here, and this is equal to, do you observe, cos theta, cos A cos B plus sin A sin B is what I have over here. Yes, do you observe that? If I take this over there, this becomes cos A cos B plus sin A sin B form. What is that equal to? That is cos of, this is cos A cos B plus sin A sin B, that becomes cos of A minus B. Okay, so I can write it as cos of A minus B, this minus this or this minus this, whichever is okay. So theta minus theta by 2 will be theta by 2 minus phi by 2. This is theta minus phi by 2. That's what I get, right? That's the required equation for that line passing through the 2 points. Okay, Now we have seen the 2-point form of solving this particular equation, and with the help of that we have obtained this equation. I'll explain one more form before we conclude this question, but let's solve the question further first. What do we have? Find perpendicular distance from the origin to the line joining the points this and this. The work is not yet complete. After finding this equation, we have to find the distance from origin. So distance from origin will be equal to, you substitute a 0, 0 plus 0 minus cos of theta minus phi by 2, and in the denominator you have this square plus this square under root. Cos of some angle, sine of same angle, square and added will give me 1, and this is what you get. So this becomes distance from the origin as actually equal to cos of theta minus phi by 2, and you have a modulus. Don't forget that. That's my answer for this question. Okay. Find perpendicular distance. This is the perpendicular distance of finding this. Right. That's the solution of this question. That's a complete solution. Yes. But one important thing remains, and I'll explain this particular equation in another way if you can handle that much. So what does that solution look like? Let's take a look at that, the other approach. So the important thing for us over here is this, that if you have the points cos theta comma sin theta and cos phi, you have this point cos phi comma sin phi is the other point, right? What do these points look like? What do these points have in common? Do you remember studying trigonometry? And in trigonometry we saw these kind of points, right? These kind of points lied on something called a unit circle. This is what a unit circle look like. This is the radius, this is -1, this is 1, this is -1, and if this angle is theta, then this point P will be cos theta comma sin theta. Okay, and similarly if we have another angle phi, then this particular point Q becomes this, right? That is something which we had from there. Okay, we'll borrow that concept first of all, and once we borrow that concept, see where does that take us. So once we have borrowed this concept, let me draw a bigger circle and see where does that take me. Okay, this is x-axis, this is y-axis, okay, and this is a point P which is making an angle theta over here. Okay, this is point P. Then there's another point Q which is making angle phi. This total angle is phi, right? Yes. Okay, and if you want to find the equation of this PQ extended, basically, if you want to find the equation of this PQ, what can you do? Observe carefully, right? This is unit circle, this is also unit circle, and if you know, maybe if you can somehow find this perpendicular distance, if you can find this perpendicular distance directly somehow, then you can write the equation as well in terms of normal form. What does the normal form look like? X cos alpha plus y sin alpha is equal to P. This is what the normal form looks like. Yes. So for normal form we need this pseudo distance P and this angle over here. Okay, and how do we get those angles and distances? Please observe, this is 1 unit. Yes, if I can somehow find this angle over here, I'll be able to add theta and get the complete angle of alpha, and I'll also be able to use this triangle, this right angle triangle over here with this hypotenuse to get P easily, right? Okay, so let's do that and see where does that give me. So this difference of the two angles, let's take a look at the difference of the two angles. This angle, what is this angle equal to? This angle is equal to, since the total is phi and this is theta, this here is theta, this is phi, so this angle will be phi minus theta. That blue angle will be phi minus theta. Yes, okay, and half of that is this orange angle, and yes, this orange angle will be phi minus theta by 2. This is what I observe. Yes. Okay, so what will alpha be equal to? Alpha will be equal to this angle orange one plus this yellow theta. So this is theta plus this phi minus theta by 2, and this actually becomes phi plus theta by 2. Okay, so you have found alpha, right? Once you have found alpha, you can you also find this particular distance P with the help of this right angle triangle over here? Yes, maybe we can do that. Let's try to apply that right angle triangle idea and see where does that take us. This is 1, this is P, and this particular angle is that orange angle, phi minus theta by 2. So this is adjacent, this is hypotenuse. What we will be using is cos theta. So P upon 1 is equal to cos of this angle over here. What is that? Phi minus theta by 2. So that tells me P equals cos of phi minus theta by 2. And this value can be positive or negative, but since P is the distance, yes, we'll have to take the modulus of this. Depending upon the values of theta and phi, this can be positive or negative. So take a modulus over there, and this is what it looks like. Oh, we have found the perpendicular distance directly over here. Yes, we have found the perpendicular distance directly over here. That was a question that was the result you obtained in the question, actual solution over there. But yes, with the help of this P and this alpha, I can also write the equation. And you observe x cos theta plus phi by 2 plus y sin theta plus phi by 2 is equal to cos of theta minus phi by 2 is what you obtained over there as the equation. Right or not? Yes. That was the equation that you obtained over there in the solution, right? Let's take a look at that again. And yes, this was the equation of the line, and this is the final distance that was required for that equation. Yes, that's the complete solution, and we have seen another approach for getting the same result for this fifth question. You can take a look at this complete solution